Okay, welcome back. Hope you found that vSAN lab pretty interesting. Sure enough, when you have a policy that is not valid, you certainly can't apply it to a virtual machine unless you force provision it. In any case, let's take a look at one more way of using policies, and that is using virtual volumes. This was actually added to vSphere 6, so it's a little newer than vSAN, which was added in vSphere 5.5, but there's actually some pretty common characteristics between virtual volumes and virtual SAN. Our goal here is to recognize the components that make up the virtual volumes architecture and be able to explain the rule set for creating virtual volume storage. But let's just understand what virtual volumes are to begin with. So, like I said, there's actually a lot of similarities between virtual volumes and vSAN. They're both object-oriented, right? So the objects that you have in vSAN are almost the same objects. They're pretty much identical in virtual volumes. So you have objects that represent the virtual disks, the delta files for snapshots, the memory state files, the vSwap files, and then what they call the configure for representing the VM's home folder. But in any case, they can all have different policies as well. So that's also another thing, right? Virtual volumes has a policy-based model, right? So it's storage policy-based management on software-defined storage that allows us to put the VMs as first-class citizens. So as we see here, it says virtual volumes abstract storage containers, replace traditional storage volumes based on LUNs or NFS shares. My goodness, what does all that mean? What we're saying is virtual volumes no longer does this other layer of abstraction of things like LUNs, right? LUNs is this layer of abstraction. Basically, the fact that we've been using LUNs just because was there before vSphere, right? So we had to use a SAN for vSphere. We were then using LUNs. And so that became the model. But you know what? That's just another layer of abstraction that puts VMs as not first-class citizens. What if we actually just made an entire array enclosure of just a whole pool of disks, right? One big pool of disks for an entire enclosure, or however big you need it to be. Virtual volumes actually has no max size, so you can have your container, we actually call it a storage container, which might consist of one or more storage enclosures. That all depends on how the storage vendor has implemented virtual volumes in their environment. All we need to do, and well, not really us, but the storage team, what they do is they define a pool of disks and assign it to probably a department. Right, so you might give a pool of disks to engineering, give another pool of disks to finance. Those are two different storage containers that are made up of all kinds of different disks. So they don't all have to be the exact same type of disk because, well, they all have different capabilities. They can then be presented through VASA. You need VASA for virtual volumes to function. So your storage container present to vSphere, that's basically the equivalent of what we would have used as LUNs in a traditional model, right? You'd have a LUN up to 64 terabytes and it would be built with a RAID configuration. Well, no, here a storage container is just a pool of disks. One big pool of disks with all different capabilities, no max size, and then you present the capabilities over VASA. Then rather than arranging storage based on features of a storage system, virtual volumes arranges a storage based on the needs of individual VMs. So the VMs, like we said, are the first-class citizens. You define exactly which of those features in the pool of disks you would like your VMs to be able to use, right? Well, that storage infrastructure may provide offloading capabilities of things like replication, encryption, compression, caching capabilities, offloading of snapshots, lots of things that the array can provide in a storage container, and then we can pick and choose which of those capabilities would apply to each of the different policies. So the one big difference between virtual volumes and virtual SAN is that virtual volumes is all external storage. vSAN, it's all local direct attached storage. So as we see in our picture, vVols or virtual volumes work with fiber channel over Ethernet, iSCSI, NFS, your typical external storage configurations. So the thing about virtual volumes, though, is there's a lot of terminology we have to kind of get a handle on. So we've been talking about virtual volume, or at least we've been talking about storage providers. What are the virtual volume storage providers? Well, it's basically a VASA provider that's advertising our capability for supporting a virtual volumes. You'll need to define, or the storage team will need to define what are called protocol endpoints. Protocol endpoints are basically where the I/O channel is connected from the array to your storage infrastructure. It's basically the replacement for the LUN. Right? When you scan for storage, for instance, in normal traditional storage, you see LUNs. In the case of virtual volumes, you see protocol endpoints. So the interesting thing, though, LUNs have no max size. LUNs have a max size of 64 terabytes. Protocol endpoints have a max size of none. Right? They don't have a max size. Protocol endpoints basically map the I/O to a storage container. So remember, that storage container is just this logical grouping of disks that can then be presented. So it's generally one for one, right? A protocol endpoint is then associating a storage container, and another protocol endpoint would associate another storage container. And then basically you rescan your storage from vSphere, discover all the protocol endpoints, and then basically map them with a virtual volume data store. It's not like a formatting of a file system here. It's mapping out the infrastructure of disks, the pool of disks, so that the objects can then be mapped based on what their policies are. And by the way, what are the objects? Virtual volumes. So that name, virtual volumes, is actually defining the objects in that file system. So let's take a look at what all these definitions look like as images. So here we have our storage container. Right? First of all, we have a storage array. And then we have our storage container, which again, this is defined by the storage team, how big or small that is. And generally, you'll probably create a storage container to a department, for instance. You need a VASA provider, right? That's providing virtual volumes. And this is going to list out all the different capabilities of our storage container over to our vCenter system so that we can find out what are all the different capabilities. And then you create a policy around which capabilities you want to apply. And then this bidirectional VASA provider will then leverage the policy rules and enforce them as the actual objects are placed out into the storage container. Now, the other term we need to learn is this thing called a protocol endpoint. That's the I/O mechanism for the actual disk I/O. So the VASA is really just providing directives, whereas the protocol endpoint is where the disk I/O takes place. It's like I said, it's where we usually would represent a LUN in a traditional SAN type of infrastructure. So the protocol endpoint is basically mapping the storage container's I/O through to the vSphere environment. Right? As it says here, the SXI uses protocol endpoints to establish a data path on demand from VMs to their respective virtual volumes. These protocol endpoints are then configured on the storage system, including one or more or several per storage container. So you can have multiple protocol endpoints for multipathing purposes. Each virtual volume is bound to a specific protocol endpoint. A single protocol endpoint can connect to many virtual volumes. So remember, what is a virtual volume? It's an object. Basically, a VM is going to be made up of multiple objects, and so therefore a VM is going to be made up of multiple virtual volumes. So again, you have potentially multiple virtual volume data stores. A virtual volume data store is basically mapping to a storage container. Its I/O is handled through protocol endpoints, and these virtual volumes are then going to be the objects that reside inside these storage containers. So a storage container is basically part of that underlying hardware. Logically groups your virtual volumes based on the management and administrative needs. So again, you can create storage containers for maybe different departments, different service levels. However, an organization and a storage vendor would recommend this. This is actually one thing about virtual volumes. It's really heavily based on how the storage vendor is recommending to set up their configuration. And then making use of the VASA API, we can learn all the different capabilities that the storage array is able to offload onto the array itself. So again, the virtual volumes are the actual objects that are part of a virtual machine. So if a VM is going to be made up of 5 objects, it's really made up of 5 virtual volumes that will all reside in the same storage container typically. Right? Virtual volumes are not pre-provisioned, but are basically created automatically when we move any VM management operations. Again, working on fiber channel over Ethernet, iSCSI, NFS, it's pretty much any kind of external storage. So let's take a quick break. We'll come back and do a little bit more on the actual policy management for our virtual volumes coming back after the break. So we'll see you in a few minutes.